There we go. Great. So for part one, we're looking for a design narrative, and that can be either written or through diagrams. And I can show you some examples of both. I mean, written is pretty straightforward, but diagrams are stuff that I'm looking for, like very similar to big, Bjarke-Ingels diagrams or MVRDV diagrams. Something that just it diagrammatically shows your design process, your design thinking. And those, I'm going to leave those as flexible as you can, so I'm not looking for any particular size or style, but even though you should probably follow some of the graphic standards of just having a white background and just clean line work and with some nice shading on the shapes. But that's really what the design narrative is all about. It's just, I want to see your design, I want to see your thinking, a process of how you came to this conclusion to this design module or ideas of the design module. And through diagrams, I want you to explain how the variations of this diagram, this design module. This design module has to be manipulative. It has to change. It has to have variables to it. And we have to, and I want you to be clear and state what those variables are. How is this thing behaving? How is it responding to things? And also, I want you to start to understand how this thing is starting to connect with other modules and to the building back. So some real early studies of just structure, how this thing holds up. Is this thing actually the structure, or is this thing a secondary skin? Is this integral to the wall assembly? Stuff like that. What is this thing? And then this is where I have two options. And I want you to pick one of them. And the first one is you physically model the 5 variations as a 4-inch by 4-inch 3D print. Or you will generate, instead of giving me 5 variations, you're going to give me 50. And I'll go through how we generate 50 really quickly. And we're actually going to automate that. So we're not constantly looking through the slider, clicking through the sliders. We're going to have the computer do that for us and export a JPEG for us. So that's what I'm looking for on next week. I'm going to bring in a few friends, and it's really just going to be a discussion. I don't want this to be very formal. I just want everyone to just have fun and just have a nice design discussion with this. This is really just part of the process. Part 2 is we're going to continue on. Now that we've started to narrow down on and refine the design narrative, we're starting to refine our modules. Now we're actually going to use these modules and generate a design out of this and clad the tower with this. And again, this will further expand into, is this thing part of the wall assembly? Is it a second skin? What is this thing? How is it connected? What's its behavior? And also, this is where we're going to be talking about the actual objects that it's going to be responding to, or actual parameters that is it going to be responding to views or daylight, stuff like that. We're going to have conversations with, and then we'll have another. Oh, and then we'll have an option for that as well, where we start to construct a larger model, and I didn't specify a size of it because at this level it's going to matter on what's the best scale this is to explain your design. So I'm going to leave that on an individual basis. So option 3 would be you either you model it and you show the connections and you start to understand how that really starts to work. Or option 4, we start to talk about the exterior renderings of it, or you actually will generate a rendering and we'll start to include some skies and context and materiality, just really something to help liven this up and start to understand this. And that's where we can get into more materiality and expressiveness of that. And then we'll have another design review. Again, we'll keep it pretty casual. And And the very last one is our final, which is where we're bringing everything together, and everything has to be put together as a cohesive narrative. And again, we pick one of the two options where you construct a large model, a 2 foot by 2 foot, and that size is can change. It's all based off individual basis, because some people's designs may be very complicated and it's just not feasible in a certain time, or there's other restrictions. But as a guideline right now, we'll shoot for 2 foot by 2 foot, and we'll have a model of that. Or option 6 is we generate an animation that demonstrates the simulation and analysis of that tower. So maybe the before and after, or an animation of how the design is responding to elements. And with that in mind, I also want to express that these design modules don't have to be static. There are plenty real world examples that these modules are dynamic. They dynamically respond to the sun, and as the sun moves, the modules move as well. Modules can move with the wind. These things do not have to be static. So keep that in mind when you design these. And our final review will be on May 12th. Once I know the time, it may be the same time that we have this. It most likely will be, but sometimes things change. But I will convey that information as soon as I can. So those are the changes. It has not changed too much from last week, but I still want to encourage the 3D printing, or if people are limited with that resource because the whole quarantine situation, we can focus more on the Grasshopper element of it. So,
I have a question real quick, John.
Yeah.
So I've been looking at a dynamic module like you were talking about, and in that instance, is the movement of the module the variance of that module?
Yes.
Okay, so I kind of have something kind of mocked up where it flares open, and that movement itself is what would be the varying shape of the module.
Yes. So, and that's the thing, define, and that's where we start to define how far open does it open? How much does it open? How much does it close? Is this a hexagonal? Is it a square? Is it what? How is it working? And what's the overall logic? Is it of this? Those are the things you're going to be describing.
Okay.
Yeah. So, is there any other questions? This is, like I said, this hasn't changed too much, but I want to actually make this flexible for everyone during these difficult times. All right, well, good. So I think a lot of today, I'm just going to dedicate for just showing how there's a lot of different ways to start to script modules and how to come up with different options. I'm just going to go through an example of how to come up with a module just through scripting. And then when we have time at the end, I was just going to review people's questions, any progress that they want to share. And like the final thing is for next week, please PDF everything that you have, PDF everything, put it together as a quick presentation. The way I see this is we're just going to, it's more of just a dialogue with everyone. I expect everyone to have something to share. This is, even though I want to keep this casual and just as a discussion, this is still, you have to present your work. So please just be prepared. And And yeah, we'll just go one at a time, and hopefully I'll have 3 other people join us, and we can just have a discussion of your work, and how, what's the good, where can we enhance it, where's different opportunities that we can take it. And so it's just trying to, like I said, just more of a charrette. So with that, so I just opened up a blank Grasshopper script. One thing about modules are they can take a lot of different forms. You can script it in a lot of different ways. This way for me was just a way that for me I like to deal with a lot of points and lines. So this for me was a pretty simple way of how to start to script a module and how to start to lay out these parametric walls. So the first thing is most of the time these are defined by 4 corners. So I'm just gonna, as an example, I'm just gonna get 4 corners going. And I'm just gonna make these up of points. And I'm gonna bring these points into Grasshopper. Let's copy these up. And I like to, when I reference things from Rhino to Grasshopper, I like to arrange my Grasshopper script in a similar way. So when I have this is our point 1. So I'm going to label this as point 1. We have point 2 over here. We'll do point 3. And the way we're labeling these, they're going to be important down the road. So we're going to start referencing these in. We're going to bring our points into Grasshopper. All right, great. And we're just going to hide these for now. We don't need them now. Let's just start. And I just want a simple, and this isn't a module that I'm going to 3D print right now. This is something that is just simple, made of lines. Later on, can I start to make it watertight, add some thickness and 3D print it later? Absolutely. But right now, I think for this example, with a time restraint, I'm just going to do some 2D line work. But we're just going to get a simple line going. And we're just going to take a line and we're going to connect it from point 1 to point 2. We're going to do the same thing. We're going to point 2 to 3. Yeah, there we go. All right, so we got our kind of like the perimeter of our module that we wanted. And in this case, we're going to, let's draw a line in the center. We need a center point of this. So we're going to get a point on curve. Actually, we're going to add another point. Actually, yeah, we are going to get a point on curve. We are going to get a point on curve. We'll add a point soon. And we need another line. We want a point that's somewhere within this box. And that's the key, is just keeping this flexible and malleable, and just let the design process flow of, we don't know what this thing could be like. We don't know what some of the benefits are and how we can do it. We're just trying to create a logic here. So we're just going to create a line, and we're just, all right, there's point 2 and point 4. So we're just going to grab point 2, point 4. And there we go. We got a point, and we can, all right, it can either start, we can start to investigate, is it going to work better when it's in the center, or is it towards one of the points? And that's all going to make a little more sense in the end, because we're we're all just creating a logic, and the variables later on can be narrowed down and refined later on. But we're going to add something three-dimensional to this. So we're going to use an SDL line. So our starting point will be here, and our direction. Now, in this case, in most of our cases that we were working with, the direction would be Z. In fact, right now the default is Z. But in this case, this module, we're not really sure the direction of what this module can be. This module could be standing up straight. It could be going more towards the Y axis. It could be going all sorts of directions because it's a module and it's going to be referencing a wall. And so that's where it's really important to keep it flexible, because right now D is referencing the world coordinates. It's not referencing the coordinates on that center point. So what we're going to do is we're going to create a plane, and this plane is going to dictate whatever orientation that point's going to be on. So we're going to use a component called a plane 3-point. And just like this plane, the XYZ, it's referencing, coordinate 0, 0, 0. Well, we can create our own little mini origin points that this is referencing. So that's the very first thing, is the origin point. What's 0, 0, 0? So we're going to put our point here. In fact, I'm going to keep this simple. I'm going to put this as point. We'll put this as 0.5 for us, just to make things a little easier. Our origin is at 0.5. So then it's asking, you have the origin, what's the X direction? Well, we're going to say the X direction is 0.2. Right? We're referencing that. Well, then it's asking us, what's the Y direction, or the orientation point? Well, we're going to put that at 0.3. It's almost like physics class. You have the right hand rule. You have X, Y, and now you have Z going up. That's exactly, that component is the component that it's trying to I guess that's how I reference that component. It's looking for, the X, we give it the Y, and now it knows where the Z is. So, so we're going to give it to C. And see, there we go. It just created a plane. And wherever this goes, that plane is going to follow, and it's going to reference point 2 and point 3. And we're just going to take that plane and we're going to just plug it right into D. And now our length. What's the logic for our length? Well, we could just have a static number. This could just be a 5 or something, but we're going to make this parametric as well, because we may not know. So we're actually going to define it by a point, and we're just going to, for right now, since we're just working very conceptually, we're going to keep it very simple. So we're going to grab a distance component, and we're just going to measure the distance from 0.5, and we're just going to reference this point right in to Grasshopper, and we're going to just label as attractor point. Actually, we're actually going to make a series. We're not going to reference that point. we're going to construct point. And we're going to start. How do I do this? Yeah, we're actually going to construct a point, and we're going to start this at -10. Oops. Get a slider going first. And then we're going to keep it at, we're going to start -10, and we're going to jump up to 10. And we just want a point that moves along, we're going to say the y-axis. There we go. And so spits out our point. We're going to plug that right in, and we're actually going to label this as tractor point. And we're going to plug that point into the distance because, again, we're still, I don't want this to be a fixed variable. I want this to be parametric. So we're just going to reference this point, and whatever the distance is between that point, 0.5 right here, to our tractor point, we're just going to keep that, we're just going to make a relationship out of that. And we'll add a division, and we'll just say 25 right now. We'll just give it a large number so this thing isn't going skyrocketing. So, all right, great. That gives us a number, and maybe 25 is a little too high. We'll do it 10. Great, and so we start to see, and if we want to, if we want this thing to go up, I believe we just multiply that. Or I wonder if we can reverse it. No, that won't work. Oops. Actually, it will probably fix it. We'll deal with that a little bit. So then we'll put the line into that. So as this as this slider moves, okay, great. We know that that line is growing. So we have a little bit of something we can have a little bit of a relationship with for that. So we need another point because I want this to be a surface that it can respond to. So we're going to get a component called endpoints. And for endpoints, it references a curve, and the output of endpoints are 2 points. It's going to give us our start point of the curve and the end point of the curve. We're just going to put that there. We're just going to say the end point right there. Great, and we're going to label that as 6. Actually, we will name it 5 prime. So we're going to make a surface out of this. And we're going to get a component called 4-point surface. And even though it's 4 points, it can create a surface that is made up of either 3 points or 4 points. But it can't be of 5 points. So we're just going to take, let's see this. So we're going to take our point 1. We're going to take point 2, put that into C. We're going to put 0.5. There it's our surface. We're going to copy this over because then we're going to take 2, plug it in, 3, plug that in. Over 3 goes into A, C, great. Or copy that over. Great, we have 4 here, that'll go into A. All right, great. All right, we have this nice little surface. Great. And things are getting a little messy right now, so let's start turning some things off. So we don't need our curve on. We don't need this point on because we're referencing that. We don't need a lot of these lines. So in fact, we're just going to really, the things that are important are point 1 through 4 and our 5' curve. Oops. Definitely need that enabled. Great. We'll keep that line on. We can unpreview these. We'll get that one going. Actually, we'll preview that one as well. So it's just real simple. And so we should get, as that point moves. Oh, sorry, that's the division. As this point moves, our thing should breathe. So, okay, cool. And then we also have that option that we can start to understand how this moves around. So this is where we can start to describe, okay, how is this thing actually going to behave? Is this thing, what are the variables that are going to make this thing move around? And, is this variable important to have, or is it really just a static, or something that later on we want to keep it static, or is it actually responding it? Or can we have, this variable, respond to something different from the other thing? Can this thing, could this actually respond to, this part respond to daylighting, and this element respond to views? It can be we don't have to pick one variable. It could be several items that this object is responding to. So once we have that put together, let's start looking at a few options. So we're going to, and we should actually, I'm going to show you this. So there's a popular add-on called Weaverbird. And this is, if you guys purchased the reading earlier in the semester, the reading actually goes quite a bit of length into what Weaverbird is. And Weaverbird is a mesh smoother. So what it converts meshes, and it takes meshes and it adds faces to them and it smoothens them out. And this is how you see a lot of Zaha Hadid stuff, or a lot of very highly organic architecture or designs come about, because it takes these very rigid forms and it can soften them up in very interesting ways. So if you're interested in that, you can go into, in fact, you probably just Google Weaverbird. And the download is very simple now. So yeah, Weaverbird Topological Mesh Editor. And really just download this. And really after that, you unzip it and you drag and drop it right into the Grasshopper canvas. And it continually updates for you. So it's very easy installation, but it's a very, very powerful tool, because we can start to, maybe this isn't a rigid structure. Maybe this is a very organic structure. Maybe, if this was very rigid, maybe this was made up of, 4 metal panels. But maybe I don't want metal. Maybe I want this to be concrete, and the panels are casted in concrete. So what we're going to do is we're going to get our join, B-rep join, and we're going to take all these meshes or all these surfaces. We're going to join them together. And we're just going to unhide that. Now it's we're going to mesh it really quick. Mesh B-rep. And we're going to take that mesh, or we're going to take that B-rep and we're going to convert it right into a mesh. So meshes are, and when we do this Weaverbird, it gets a little tricky, because if I have a mesh that's made up of several faces, and I'm trying to mesh it all together and have it smooth out, it's going to behave differently. So what I mean by that is let's just bake this really quick. And I'll show you why we created. So all these had to be created exactly the same way for this to happen. Oops. And that's because of the faces that are made up. See, all these are our ISO curves that make up the faces, but these also help us understand how these are going to be made up with a mesh. And notice that all of these intersect each other. And that's very important when we start to deal with meshes and Weaverbird, because we want these to intersect, because then they're going to create a nice smooth feel. If this had different intersections and it was made up of much more faces than this, it may have a very different result, or it may not work the way that you predicted. So that's why all these faces are made the same way, so we know they're all going to work well together. And I'll show you why. So all right, so we have our mesh, and we're going to go into our Weaverbird, and we're going to use a Catmull-Clark subdivision. And it's called Catmull-Clark subdivisions because that's the person who wrote the equation way back when. All this is just through calculus and how these faces are subdivided. So right now, not very organic, right? It's pretty flat. It still has the rigid. And what is this component looking into? This component is looking for a mesh, and then the number of subdivisions we want it. And right now it's set to 1. And then our edges. How do we want to address the edges? Right now, all the edges, are smooth. And maybe that's not the right way we want to go about this. So again, all depends on what this is and how we want it to behave. So the first thing is, let's smoothen this thing out. Level 1 is the lowest. Level 3 is the highest. So we're just going to say, get our slider. We'll start our Mintua, and we'll do 3. Now, if we can put like 4, but when we put 4 in there, it'll start to glow orange, just saying, hey, it doesn't work. We'll just give you a 3. But when we crank it up to 2, we notice it gets a little smoother. Crank it to 3. Okay, now that's pretty smooth. And we can start to see how this behaves a little differently now. It's a little more organic now. we also can start to address the edges. Maybe we don't want it to be this, maybe we do want the corners to be fixed. So we can put a slider in there and input the value. It does tell us the value, we could put 0, 1, or 2 in, or we can just right click it and they have an option of, we can do it fixed. So the edges are fixed and now it becomes this little droopy surface, or we can do corners fixed. So now, it goes back to that. It all depends on different scenarios, but we'll keep it fixed. We want this to be a module. Great. So this is getting a little difficult to read. So we're just gonna get a mesh. We're gonna call it a module. We're gonna preview that, and we're gonna get a preview, custom preview. Put that in there. Unpreview that, and we're gonna get a maybe we want to deal with a little transparency. So I also want to keep this thing a little, maybe we want it to be a little darker. Maybe we want it to be solid. Maybe that will help. Maybe we just try to change this up so it actually is moving up. We can just do this. Oh, I thought we could do that. I lied. Maybe we can't do that. Oh, because that's, no, it really doesn't like that. Oh, my bad. I thought we could probably, thought that would work if we multiply that by -1. So maybe we would have to flip the, all right, maybe we don't get into that because then I gotta flip my planes. Yeah, maybe I don't do that, get into that. But is it really just that? Yeah. Yeah, it's weird. Even though it says reverse multiply by name. I'm pretty sure I did that. Okay, well it's all right. We got our, so it's sticking out like that. We mess around with some of that. So, all right, so cool. We started to get a module. So let's start documenting this thing. So we want a couple iterations of this. So let's get into view. Sure. View capture. There, Ladybug view capture. So we should all have this because we worked with the Ladybug plugin earlier in the semester. But what this does is it captures this, whatever view that we want it can capture that. And we can tell it to, we can name it, we can put it in a folder, specify the viewport they want it, specify the image width and height, the display mode, all that stuff. It's a very powerful tool because it can start to automate like a lot of our documentation from this. So file name, we'll just call this actually, what we're going to do is since we're going to have so many files for this, so many images, what we're going to do is we're going to identify the parameters of what define this. So what defines this module? Well, definitely the location of this. So we have 20 of that. We'll also have, you know, we can say this is one. So how about that? How about we, the variable that, but we're going to change this variable. Instead of a point on a curve, we're going to put it on evaluate curve. It's important to say we do evaluate curve just because we have a slider that goes with it, and the slider is important for this. And you'll see why in a second. So we'll plug in our C into that, our P, our point to point on the curve. Yep. And we're going to put we're going to do this as a slider. But we're going to change this up. We're actually going to make this 0.1. So we got, all right, good. That's going to give us 10 options. So that's great. There we go. Now we got our values back. And also be very careful when we do this on the number of like your range, your domain and range on your sliders. And again, this will be very important. So we're going to also help name this file. We're going to use a concatenate, which is a really cool. It's a great way that we can start to edit and manipulate some of the. I mean, it's great for just data trees. It's great for labeling because what we can do is we can insert fragments into that text. So we can say, you know, design module. Maybe we'll just have a comma. This is also great when you work with CVS files or CSV files because CSV files, they jump to columns when you add a comma. So it's just another way you can control like an Excel spreadsheet. It's just a great way to control some outputs. So we're going to put this value in. And then we're going to put another value in. And that will be this one. Right. Oh, my bad. I'm going to put that in. Then we're going to do plus. And we're going to put this value in. Great. And our output, grab a panel tool really quick. All right. So it says design module 0.3 and -5. So that's great because this tells us it's our design module, and it tells us, you know, what's our evaluate curve value and what's our attractor point value. And all that's going to matter when we start to generate these variables. So as we change that, we notice our panel is going to change as well. Great. And actually, we're going to make sure this doesn't go to 1, because when it gets to 1, it's flat, and that's not, we want a flat surface. We're going to make sure that's, we're going to make sure that's at 0.1. So it doesn't get to 0. We'll keep that at 1. Did that just? There we go. Anyone else see him? That's weird. Why did it do that? Okay, that's really weird. So then we'll get that at, so our range should be 0.9. That's so weird. Okay, that's strange. But the extra one, I mean, it'll air out, but it's not going to do anything. It's not going to hurt us. It's very strange. I might be missing something like that. But anyways, we can keep track of that. And we're actually going to plug that in to our file name. Our folder, I'm just going to say, we'll do it the old-fashioned way. We'll do panel. We're going to start a new folder, and we'll just call it design module. And it's very important to do the design module folder. Open that up, and we're just going to copy address as text. Get our panel tool. Get that in there. Great. And we're just going to plug that right into the folder. View name. We're going to we're going to make a view really quick, and we're just going to see set view, named views. I want to make sure. We're going to minimize that. Okay. And we're also going to turn off our background. I want to make sure that we're shaded, but solid color, iso curves, edges. We want our grid all turned off. It's nice to have the points in just because we can track our variables, and graphically it's whatever your preference is, but in this case, I'm just going to turn them on because keep them on just to show, but you can keep them off. Great. So image view, we'll get, and again, it's one of those tricky ones where we need to spell it exactly. Few names. Image width. It gets really important to just keep it a smaller number, just because this thing could get out of control. I've had this crash my computer or just have it tidied up for about half an hour. So we're just going to keep it pretty small at 600 pixels. And display mode, it should just be, what's that it's referencing? We'll do shaded. Make sure that's spelled correctly. It's, yeah. Keep aspect ratio. We're going to set that to true. We're just going to get a Boolean. And all this stuff is just actually, it's just, display options that we've seen in the past and just with Rhino. Transparent background, yeah, that's pretty, we probably want that, make it a PNG. Set to true to have a transparent background. Yeah, we want it transparent. And capture. And when we capture it, if we set this to true, it should automatically put an image Set to true. Let's go into our folder. Oh, there it is. Let's double check it. All right, that's really small. And our variables are huge. So maybe we maybe crank that up to 1,000. Let's see again. It saves right over it. Okay, that's a little better. Cool. And I think, hold on, I think there is am I missing one more? I think there's a record I'm missing. God, I thought I had a record. Okay, no, I guess that is, that's all it is. Because then there's there's a reason why there's a data recorder, and I might have to but it may be you know, it was a different project I used this on, a data recorder, but we're gonna type in fly. What fly does is it's going to run through all the selected sliders that we plugged in, and it's going to run through all of them. And so there's going to be a lot of warnings of when we do this, because again, that's why I mentioned you got to be careful with your domains and ranges for your sliders, because it's going to run through them all and it's going to create a lot of images. So we're going to put this slider in. We're also going to put this slider in. And we're going to get our Boolean toggle again. Make sure it's kept on false. And we're just going to go into our folder really quick. Just gonna make sure. We're just gonna delete this really quick. All right, great. So we should have all this set up. We're just gonna set this to true. And it's going to give us a warning. It's like, hey, these are the two sliders that are connected, and with the combination of these sliders, it's going to create 231 iterations. Are you sure you want to do this? And so we're going to say yes. And it's going to run through all our iterations. And this is where the computer is just like, oh my gosh, this is too much. We're going to give it a second, because right now, we look in our folder, it's creating 231 images, and it's running through all the different iterations and make this up. And is it done? Might be all done. That wasn't that bad. Yeah, 200. Look at 231 items selected. Great. So then we get to. All right, great. So then we get to see how all these start to behave and different modules. But some of them, so it's great. We just created 231 object variations of our design module. But really, this is just half the battle right now, because you created 231 design modules. So what? What does that mean? What does that mean to your design process? What does this like do? And that's where, that's why Grasshopper is just a tool. It is not. It is something. It doesn't come up with the design. It's just a tool for us to evaluate designs, because now we have 231 objects. What are we going to do with them? how are we going to even sort through them? What's the difference? What, is this design module better than this one? Really, why, what's the difference between this stuff? And that's the important thing I want to stress as Grasshopper and all the software, that these are tools, and it's a paradigm shift of how we're using it, where we're no longer, so we're not restrictive of just making 2 or 3 iterations, where we can make thousands of them very quickly. But now the design process changed, because now it's all about how do we evaluate the design and how do we edit this to pick the ones that we want. How do you even begin to categorize these as one versus the one's better than the other? Is one more performative than the other, or vice versa? How does this work? And that's where the design narrative comes into play. So what? You made all this stuff. What does this mean to your design narrative? What is this? Are you going to take every other one? But why would you do that? And that's where I want you guys to reflect on that, is like, what can I do with all this? And the answer is always going to be something that's going to be reflective of the process or the context of what you're trying to do. With going back to one example of mine with the putt-putt, we use this as an example. We made those 2,000 iterations or 8,000, and at the end of the day, it was like, so what? What does that mean? Well, what we did was we took all those and we started to categorize them based off of their variables, based off what made them, and we assigned certain values to them, and from that, we were able to pick and choose certain ones that we liked. Or not that we like, for what we liked, but also what made the golf course more challenging. So it's a tool. This isn't the end. This is, like I said, you are halfway through now. Now it's time to put the theory and process into this.
John, I had a question real quick.
Yeah.
So you design your modules, and then you assign a value to them in terms of whatever it is that you're, like if it's a view or sun, stuff like that, right?
Right.
Once you kind of assign that value and let it play out, is there like secondary? I might have to rethink what I did for my pattern, but for my modules, because there's like one module that you can rotate it differently. So is there like a secondary way to like have it rotate, or do you have to just manually go in there and flip it, or should I not do that at all, I guess?
What do you mean by, is it the actual model itself is flipping, or is it I have two modules right next to each other and one is the mirrored image of the other?
I have both.
Both? Okay. So
we could talk later, but just to know, is there secondary? So once you assign the value, can you assign a secondary value to have it behave a certain way, or is that?
Yeah, you can. Yes, you can. And you can have, so like with this one, this was all based off an attractor, right? But the evaluation of how I evaluated this, like the curve evaluation, that could have been, that value could have been, another attractor point. Is that what, am I answering that correctly? Because like it could be another variable, and it's all, you can script it any way you want to, but it's just how, I guess it's how it's just the logic of how you want it to respond.
Okay.
Yes.
So I have a question on this. What would your narrative be in creating this module? So I guess, are we coming up with a narrative on why you chose the 4 points and why you made it respond to a line on a curve? And like, are we creating the narrative around creating the actual module? Or
Yes, and yes.
okay, so what would you say? I mean, because you kind of just started putting a script together. So what would you say your narrative would be to creating this particular module? Because I guess I'm trying to like get from my idea to the script part, and I'm missing something, I think.
It's so it can go back to, with this, I think it's laid off. You can describe that as, this is, the logic behind this module is right off the bat would be like, it's going to be a rectangular grid. Why? A lot of it could be based off the context. This was really just made up out of thin air. If this was in a very conservative area where when we're during a time in the economy where things weren't doing very well, so being cost effective was very important. So we say we established that grid. Why? Because that grid is a very cost effective way to do this. We created this slump. Why is that slump there? It goes back to what's the big idea that you're trying to get. Maybe go back to, maybe it's we can go back to the ladybug reference where we're looking at the solar studies. This spot is located in Washington D.C. and there's this important architecture building that I'm directly responding to that has this style, and that's what I am coming up with. Or maybe going back to, this is a, maybe it's not the slump, but maybe it's a square opening. And you can say, and the square openings varies in sizes, and it's like we kept this square opening, and it, because daylight was important, or responding to daylight. And, since this is predominantly an office building, there's been several studies that show that this controlled daylight, encourages productivity and collaboration between employees. Stuff like that. That this isn't just I just came up with this shape. Why do you came up with it? Because it was cool. Anyone can do that. Look at, it's maybe materiality is very important to you. So maybe it's metal is a very important material. So this is a rigid form, and we did a rectangular because most of the stocks for metal was through 4x8, or stuff like that starts to build up validity of this design of your module. And this first pass, this is really just, let's start to see how you can articulate the narrative. By no means is this going to be a final narrative, but it's just, we want to just hear some of your design thinking and opportunities it has. And just have a discussion around it. Like I said, I'm not looking for a final, I'm responding to the sun because of, not everything's going to be figured out. And so a lot of it may be responding to contextual things like, or it could be responding to economics, or it could be really anything. You know,
All right, I have a question.
yeah.
All right, so then are we bound to the O2A aspect of the building of being a mixed use office building with retail on the first floor?
No.
No.
If you got an idea that is like, you know, this just doesn't make any sense as an office building, you know, for this, you know, buildings change over time, you know, tenants change over time. That's one thing that we're really seeing now is, you know, even though this building was a parking structure, because of Uber and Lyft, you know, we're seeing parking structures being converted into office buildings. So nothing is set in stone. So keep that in mind.
Okay, I just wanted to know if we were liberated from the O2A aspect of this building.
Yeah, except for, you know, this still is an urban, so like usually like you keep the first floor as retail, or maybe it's a bank or something, but it's awfully a big bank, but yeah, if it has some reasoning to it, I'm totally open for that. Also, I think I've mentioned, and Ruby, that goes to your tower design too. It's like some of the tower designs, it may not make sense to have every surface of it cladded with this. It may, like Ruby's, yours is like a corkscrew, so it may make sense just to select one of the sides or two of the sides. Yeah, I'd probably pick two of the sides. And have it and clad it, just because your twist is so tight. So it's just, you know, you guys have that freedom to it. This could even be a second skin to it. You know, maybe you don't follow the building exactly. Maybe it's very prominent on the top, and then it slowly erodes away at the bottom because, well, you know, there's not much sun. You're not going to get a whole lot of direct sun down there because of our contacts. You know, it can be it can be a secondary surface. It can be the entire wall assembly of it. It's but that actually kind of gets a little bit into module part 2. But this is but just things to keep in mind. Yeah, this and just keep an idea of just, you know, if it's you know, a square or a hexagonal or or a triangle. It could be really anything. With that in mind, I posted up some resources up on the assignment, assignment 3, that I think will be helpful. They get involved in a little bit of part 2, but I think in this sense, it's always good to kind of keep an eye out in part 2. You know, we're still focused on part 1, but the things that we're working on do influence that. So this is a great PDF. This may mention components or I'm going to change this. I really do not like the PDF annotator. This book is old, and it's funny when I say old. It's like maybe really not even a decade old. But but in Grasshopper terms, it has a lot of things components that they probably just don't offer anymore. But this is a great PDF of just it walks you through different just some of the ideas of a parametric skin. It takes you through a whole fabrication process of it. Now, they didn't use any 3D printing. They actually did, they actually cut some tabs out and did it that way. But this is a fantastic little tutorial book that has things that they're very useful, and they talk some very basics of Grasshopper. But I posted this in the assignments 3 folder, so please take a look at this. Some of the stuff I know we've seen before, and how they do some nice tips and tricks. But when we get later into the process, they'll start talking about, similar stuff that we're doing, parametric towers. They're talking about, skins and how we can clad these. And then all the way into how do we even start to fabricate this. So there's a lot of great resources in this. That I highly recommend just glancing through this. We talk about attractors and curves and all sorts of stuff that I think is really good. Even how we start to get into some waffle structures, projection, and actually into the skin, and how they start to fabricate them, and analysis. So again, I think it's a great read. It's a huge PDF, but so pick and choose what we can of it. But it's even gets into, some really great form finding techniques. When we talk about adding detail and understanding how these things are connected, this is a fantastic little tutorial on how to do this. Especially into like parametric skins and how they can respond. And I particularly like this one, just because it's if for those who are maybe not very comfortable in Grasshopper yet, this is I think a fantastic alternative. It's like a nice hybrid between Rhino and Grasshopper, where they actually designed the module in Rhino, and they were able to create a skin, use Grasshopper and apply it as a skin. So a great resource. The other one is, and I apologize, my my resource of being readily available of a scanner is really limited now. So these are from the textbook that I recommended at the beginning of the year. Again, I apologize, these are not the best, but this is just a great way, again, to walk you through a different way to do what I just explained on creating modules and then applying it to a parametric skin. And they actually start to talk about Weaverbird and attractor points, and just it does some very unique stuff that I think would be helpful for a lot of you. So that is also in it, and also it has a great QR code for your phone to start to look at. They have some great stuff for that. That's a great example. So, so we have this module. So it's kind of like, so what? We have this module. What can we do with this? How do we make this into something like how do we actually make this into a parametric skin? So we're going to get a curve really quick. I'm just going to do that. And curve. Left two.
But we got a little surface going. And then we're going to get our divide domain. I think we've all seen, hopefully we've all seen this before from the other exercises, you know, how we divide the domain. We do our ISO trim. In this case, we're just going to grab 25. We'll copy this. We'll get our ISO trim. So we're actually dividing this surface up by rectangles. All right, so now this curve is made up of a whole bunch of mini subsurfaces. We can start to change these around, get something that's a little more squarish if we want to. But there's that very important component called deconstruct BREP. So we have all these small little, so what we did was we created the surface and we divided it in the U and V direction, and that's the domain, and then then we divided that surface up by that domain. So all these are small little individual surfaces. And then we're going to deconstruct these, because right now what we want are the points for all these surfaces. There we go. So when we deconstruct it, our output is a face, an edge, and vertices. We really just want the vertices. So we're going to do our list item. And we're going to grow this because we want to list 4 points. Because what makes up what's the one thing that our module has in common with all these? They're all made up of 4 points. So we're actually gonna make this a little easier on us. We're gonna subdivide this surface into one rectangle. So this whole surface is represented by 4 points. And we're going to, like this end, we're going to get a point. All right, so this is, well, it's a similar location to our point 2, so we're going to call that point 2 prime. This is point 3 prime. That's 4 prime. That's 1 prime. We're going to arrange these in a similar fashion. All right, cool. So we're going to move this down. Yeah, we're going to now plug our 1 prime into our 1, our 2 into our 2, our 3 into our 3, and our 4 into our 4. And we're going to unpreview those. We're going to unpreview all that. And now we're going to adjust our domain. And now our wall is made up of our module. We're going to preview that just to help clean it up. And we're going to preview that to help clean it up visually. There we go. And now when we move our, see how much influence this has. When we move this, this should influence all our modules. And we're actually going to unpreview our loft. And so when we move this around, we're going to notice all our little attractors are going to change. And we're going to maybe make that a
little, maybe we'll divide that by 2. Maybe we get a little more dynamic with that. But we can also start to change that up. It's fully a parametric wall. It behaves. And then maybe we'll make that, maybe we won't make that as that. And then we can start to, actually we don't even need this anymore, so I'm going to delete that. And then we can actually start to adjust the design of these modules. Maybe it's actually justified right in the center. Maybe, you know, and then maybe that's not really what we want. Let's move it towards, you know, all of it. So it gives us our full flexibility how we want to design it. Yeah, and we start to see how all these parameters are influencing the aesthetic of this tower or of this wall. We can, and it's all controlled by this, the behavior of our skin, which would be our building facade. Kind of peel up a little bit. So it kind of swoops in. But the important thing is all these, that Z direction though is all perpendicular to that face. And that's very important because if we did not have this and we didn't, and we could just plug this in, it's gonna, watch, it's gonna flip, right? Flips on us. What if we didn't do this? What if we just got a Z and we just reference the world coordinates? All of them go up. Now we got, you know, they all just go up and now it's a flat face. And it's like, well, we're now, you know, we want that face to be perpendicular to whatever behavior of that skin that's doing. So that's why it's very important for us to create that 3-point plane and make it perpendicular so we get that definition. So you start to, and then, you know, we can, you know, you start to just start to see how this thing behaves. And maybe when we get pieces like this, you know, well, then let's start to adjust our domain. You know, our modules are getting a little too large. So yeah, some crazy stuff here. So, but yeah, that's what we'll probably, that's what we're going to be further for next week, or yeah, for next week. I won't be looking for a parametric wall at all, but I'll be definitely be looking forward to what I talked about in part 1, and just progress with that. But I am looking for all that content though, so we can have a discussion on it all, because it's all relevant on how we get to this point. You know, this is the fun. I mean, all of this is fun, but this is always where you get some pretty wild results. But we need to establish the rules of how this is going to behave. You know, the whole rest of the semester, we were trying to control the big picture of how this surface was going to get controlled, and now the rest of the semester we're concerned about how these specific modules are going to behave. But it's interesting, it's just a different way of how you know, in this part, how we design, how we're really focused on this small detail, and then how it just generates into the design. So it's a like I said, it's a little different way of how we think. So but yeah, do we have any questions?
Yeah, I think maybe this is like getting ahead, but so you design the module, you are able to adjust it, you know, by aesthetic or what have you, but where do you kind of start bringing in, you know, different elements for why you are going to have variations?
That's all that, like what kind of variations it's going to have, and like you mean like how each little module is going to respond?
Well,
guess-
yeah, so yeah, exactly. So like we have the shape of our building, so I'm not going to be moving my wall to create variations. I'm going to have variations based on some other parameter.
Mhm.
I just don't, I guess that's what I was working on. I was trying to figure out how to get variations based on a parameter.
So all that I think just is just the design and the logic of the module and how to get like some range behind it, like because the form we developed the logic of the form now, right? It's like okay, that form there's a lot of rationale why that is the way it is, and now we have to do the same thing for that module. We have to build up that rationale of why is it behaving the way it is. So to get that variation, it's all about just what is it responding to? Is it responding to the views? Is it responding to solar? Is it responding to wind? You know, it's all that stuff that we are infusing it with.
I guess I'm just having difficulty understanding how to do that.
Okay.
So like, so you have different scales and stuff like that, but if you're having it respond to like solar, you have it respond to the view, it's, you know, not a
Right.
slider. So I'm not sure how to connect the two in a Grasshopper format.
So right now we don't have the analysis, right? To prove like this is getting that range. Like we can say we can develop this module and say, well, is this this is going to respond to solar, and it's like when you can't. Sometimes you really can't do that right away because it's more of like what is the behavior of this? What do we just want to have it behave? If it's for solar, we can just say, okay, I think I'm going to create this as for solar for now. But it could later on change to like, you know, solar just doesn't make any sense. I'm not getting the variation I want it to be. Maybe I'll take a step back and maybe it's not solar, maybe it's wind, or maybe it's the context. You know, we can always like, you know, the great thing is we can always figure out that, you know, this may not be the variable that's best for us. And in order for us to know that's a variable that we want, it's through our design narrative it's through analysis, which that's where the next following steps we'll do is, okay, what are the things that we really want to respond to now? What are, you know, just having this point move across, you know, that's really arbitrary. There's nothing that says that's solar or that's wind. It's through analysis. So it's through our Ladybug analysis. It's through you know, view analysis. We've done those, but right now I'm just looking for ways of like how this thing could respond to. Not it is responding to that. You know, that's part two when we're like, okay, no, we'll define that. Okay, this is really what it's going to. That deserves another round of analysis. But right now it's just what are the variables that control this, and actually assigning those variables is not important right now.
Okay, I guess what's throwing me is the diagrammatic. I don't know if you post that PDF, but I didn't see it when I looked. But where you had your 4 or 5 modules, and then you had like a diagram of like one face of the building, and then you have your line showing how it responds to that, because that's throwing me off because I'm trying to figure out, well, what is it I'm picking for it to respond to if I have to diagrammatically show that?
Okay, no, you're right. I apologize. No, so that one big diagram right next to it that has the big swooping curve, yeah, that's like part 2. I was really just looking at those small little 4 ones. Yeah, think of how about this? What about it? Think of it like let me bring this up. Think of it as this one, and let me share my screen really quick. Oops. Hold on, my
frozen. Think of it as, sorry, this is something like this. Oh, come on. There, here we go. You know, you start to talk about the variables that are influencing what comes up with the module. You know, we first, you know, in this one, I would say, you know, it was that putt-putt was, you know, that golf. It was in this context, it was the putt-putt course. So what was and right off the bat, we wanted, you know, all these different design modules to create all these new experiences. So what's the defining characteristic of this? It's the ball. So the curve, the ball, the path of the ball was the defining thing that we wanted to have. That we wanted to influence that, because when we influence the ball, that influences the game and that influences the experience. So that was a huge factor, and that was our influencer. So how do we start to influence that? Was when we established a grid. Why did we establish a grid? Because we needed points that referenced that ball. And we created a curve, and that curve represented the curvature of the path of the ball. And based off those points, how close that ball got made the points elevated the points to a certain relationship. And from those points, we developed a skin, and that created our module that dictated the path. And this one was this was pretty simple, but it's stuff like that. Like these diagrams are the stuff I'm looking for. And just that kind of logic that what we're doing. Now in this one, you know, the influencer was known, and I kind of, you know, we kind of announced that, no, this is very important to us. So this is the thing that's going to affect the module. You can do that. You can right off the bat say, no, this view is the most important thing. And whatever that view hits, you know, that's just how it's going to hit, how it's going to affect the module. And you sometimes, you know, it's all based off your narrative. If you think views are going to be very important, you know, you can take it that you can stake and say the views are very important, they're going to be an influencer. Or you can just be like, there's a lot of influencers going on the site, or a lot of environmental factors, you know, so to respond to these environmental factors, you know, this is how it's going to respond to it, and establish a logic for that.
That's helpful. Thank you.
Yeah, no problem.
John, do you have any other student examples that you think were halfway well done from previous classes? Are we one of the first few classes to go through this?
I
still feel a little bit in the fog, and I don't know if it's.
What do we have access to that putt-putt?
I can post it up. Yeah, I'll post it up.
I think it's just helpful to see the diagrams and see some of the thought process behind it. Okay. Yeah. If you don't mind.
No, that's fine. I'll post it up. If I can find any, I'll post it up. Actually, I think I can post up a few. Yeah, actually, I have a few of mine I can post up. Yeah. I'll post up any more examples and share them on it. Hopefully that, and I'll write up an email. Write that down. They will be a little bit out of it was for a different class, but some of the logic was the same. It's some similarities, but in their case, they were responding to an existing building. and they're doing an analysis, but it's the same, very similar analysis. So
for like the example that you created in class here, where would you use something like that? Would it be like used as a second skin, almost like EFT or ETF, like the water cube in Beijing, or like the roof of the SoFi Stadium? Like, what would that materiality be, and where would you use it?
it can be either or. It can be the second skin, and that second skin can, it can be the second skin. It can be the actual wall assembly. You can have your it depends on how, it could be a load bearing. Well, probably won't be load bearing if it's curving like that, but it could really be anything. That's kind of the exciting thing. It could be that second skin. It could be that integral. There's examples of, in fact, just even finding some precedent studies of that could help a lot. There's a lot of them out there. All around the world that are fantastic. I know Zaha Hadid does a lot of it. SOM. I mean, it's starting to become a pretty big trend now. So even just a quick search of parametric walls or parametric skins are all great ways you can just find examples. And there's a lot of studies and a lot of great information on just how they fabricated them. And how and what are the items that they're responding to. And that's, I can post up some more student examples, but there's also a lot of great real world examples also as well. And just to help understand how these are made. So like I brought up the Broad Art Museum, that was all a second skin. Like behind that was all curtain wall. And that skin was all about just filtering light, because this is an art gallery. It doesn't want that direct light. It needed that ambient light. So the whole skin, that's the shape it took, was trying to diffuse that light up away from the art, but then reflect it down.
So then something like this would be used for like the Louvre in Dubai, where they created that big dome structure with all of the openings and kind of layering it up.
It could.
So
it
how
could
do they
be.
do that with like the openings then?
I'm not
It seems like the forms that were just created and kind of what you've given in the examples are solids, but like with openings in that. So like there is that view through. So
Yes.
you have the skin that you just created and you want to put like a big hole in it that like grows in size. How would you go about doing that?
Yeah, so we could, let me share. We could totally just change the module up. So maybe, maybe it's not at that organic shape. Or maybe it's a, let's just, take this portion really quick. Maybe it's, I'm just going to disconnect these really quick. Make sure I'm referencing something correctly. So yeah, so then we could just start to okay, good. So maybe we could just begin to get our curve, and we'll just join these. Not sure if this is the best way to do it. I'm sure if I want to offset it. It's all based off plane. Not sure if that's the correct one. But we're going to load it. And we do the very similar thing, where now we have our points. Get our list item. Should be 4. I think this thing does screw up. It's the offset. It's defined by the world coordinates. Really, we just do that same thing. And we get our 4-point surface. We just construct our, oh, hold on, bear with me for a second. And we simply just start to construct our surface like that through that point. So we have point 1, we'll get bring that over to us. Yep. It's there. We want to get 2. We'll get 2 here. Great. So now we want to do another one of these. So we start with 2. We go to 2 prime. Then we go to 3 prime. And then we go to 3. Start with 3. 3 prime. Go to 4 prime. And we'll go to 4. Paste. And then we start with 4. Go to 4 prime. 1 prime again. And do it 1. So now we have our opening. Oh, that's messy. Hold on. Here we have our offset. And we can do that. Do a slider. We'll do a, what's that point? Actually, we'll get this point, do evaluate curve again.
reparametricize this. 0.1. Edit this. Zero one. Get this point. Distance. And we'll just grab that point, and we'll just reference this point down below. And that output should be, we'll just plug it right into the D. So when this guy moves, our opening moves as well. And then we should be able to reference that right into our surface. And so that gives us our openings and how it can adjust. But however, I'm not, the biggest question right now is the offset, because the offset's set to the world. So that's why that's where you might need to the logic probably might be a little different, but that's a very similar way how I would do it. Any more questions? Okay, cool. Thanks, Matt, for sharing that link.
Yeah, there's that, and I'm sure there's more lists around to sign up for, but that one does like all over. There's a bunch of people around the world that are on that list.
Awesome.
There is that project that's going on in Boston right now. That if you want info, I have the STL file for it, and I can send it out if people want to email me. I can send it over.
Awesome.
And then there's other ones too.
I think this is the one that we've been using, the Sabin Labs. We actually there's a few things that I was having a little bit of issues with on how they made it, but it's because my 3-hole puncher isn't big enough. That's mostly it.
Yeah, the guy that I'm doing this for has a whole operation, so he's just getting people to send him just the head pieces, and then he's assembling all of the face shields and all of the straps and everything like that. So it's just like he's trying to produce a certain amount in a certain amount of time, and he's just getting the 3D stuff printed by everybody, volunteers and stuff. So.
That's cool. That's very cool. Great. Is anyone else?
I have one more question. I'm so sorry.
No, that's good. That's good.
So let's say you do your 50 modules, you're able to kind of spit it out and have all these different pictures, and you find 5 in there that you really love. How do you know what settings those link back to? Is there like a crosswalk to go back and like put in the settings so you can kind of work with that particular model panel?
Oh yes, so that's why I set the labels. The labels have all the settings, so it knows.
Oh, okay.
Yeah, that's why. Okay. So then it's like, oh, I really like that picture. What was the design? What was the settings for that? And it's like, oh, I know the first one is -5 means, or 0.5 means the evaluate curve, and -5 is the movement of the point. So
okay, good.
Yeah. So hopefully that helps. Yeah, and be careful with that, because I've had students like their computer crashed on them, or they'll just freeze up for half an hour or a good hour. I think so. It takes a while. So that's why I started out small with the images, like 600 pixels, just because 600 pixel image doesn't take up too much room, but
it can take up a lot of room if you're not careful. Like, let's see, that folder that we just made it's actually not that bad. It's only 8 megabytes. So that's actually really good. But I've had accidents where like I created that folder and it was like a gig, and you're like, oh, geez, I didn't mean to do that. Make it that big and take up all that space, and it slugs down the computer. So, and there's a whole bunch of other stuff too that that's useful for. Which I'll cover. I forgot. Yeah, it's another good website. It's a web-based server that I'll talk later about. It's a great design. It may not be applicable here, but it's great just to know about. It's called Design Explorer. But it's another great thing that that's one way that you set up these files and stuff. So, well, great. Does anyone else have any more questions? So great. I'll send out an email of some more examples. I'll also I want to get confirmation of the people that are attending, and I'll send you out their names. And yeah, and like I said, I think next week we'll just have all your stuff, your progress. I am looking for all those items, so I really highly encourage that all those items are in your presentation that we can talk to. And we'll just have a discussion. I want everyone to chime in and just let's see how this works out. So I think it'd be a good time. So, well, great. Well, thanks everyone. I'll post this up as soon as it's done queuing up, and I'll see you all Tuesday.
Cool. Thanks, John.
Yeah. Thank you.
Thank you. Thank you.
Stay safe and healthy.
You too.
Thanks.